Hey guys, hope you're doing well. What I'm going to be doing here is walking through some of the in-class practice. I was going to do this as two separate ones, but what I'm going to do is one video with several chapters in it so that you can kind of skip through it if you need to. I think that that is probably the best way to handle this. What you'll see on my screen right here, hopefully, is the sheet from D2L. This is the dimensional analysis in class practice that you'll find under one matter and units of measure. This is my scratch paper. And this is actually from the lecture for matters and units of measure. This is slide 34 that has all of those conversion factors on it. Now I may need more of them. If so, I'll pull up my exam handouts if I need those. And I may also need my calculator, so I'll pull that up if I need it. All right. And what I'm going to do is go ahead and walk through each one of these. I'll then try to make each one a chapter, and that way you guys can skip through them as you need. Okay? So they're not numbered, but I'm going to go ahead and call this number 1 because it's the first thing on the page. The label on the soft drink bottle gives the volume in 2 units. 2.0 liters. I'm writing it down because I write down anything I see because I may need it later. And 67.6 fluid ounces. 67.6 fluid ounces. Now, fluid ounce is not the same as an ounce, okay? There are differences in those. We talked a little bit about this in the lecture portion, and as I showed you with the exam handouts, I did provide some information. If I can get back there. Here about fluid ounces and volume milliliters, okay? But I don't necessarily have anything liters ounce type way. So that's not really helpful to me. Now, what is it asking me to do? It says use this information to determine a conversion factor, which is one thing divided by another so that we have something that equals 1 between English and metric units. English and metric. So my metric unit is this one. My English unit is this one. Since it said English and metric, I'm going to put English on top and metric on the bottom. Does it matter which way you do it? No, I don't care. Okay, I do not care. We know that that soda bottle means that both of those are equal to each other, right? That's what it says on the bottle. So since it's equal to each other, then we can divide one by the other, and that's equal to 1. Okay, so I'm going to say 67.6 fluid ounces is 2.0 liters. Now, do I need to do anything else with it? Absolutely not. That's all I need to do. Can I do the division if I want to? Yeah, of course you can. That's absolutely fine too. But it is not necessary. The way that I do my stuff, I leave it like that and I'll work with it, as I do the math going forward. But you can do the math here to figure out, how many fluid ounces per liter as opposed to 2 liters. That's fine. Doesn't matter. Okay? So that's the first one. Let me talk about the second one, number 2. The label on a box of cereal gives the mass of cereal in 2 units, 978 grams and 34.5 ounces. Use this information to find a conversion factor between the English and the metric. English, metric, English, metric. This is my English because it's ounces. This is my metric because it's grams. Okay. The same reason that I did it that way before, I'm going to do it again. It said English to metric, so I like to put the English on the top and the metric on the bottom. That's all I needed. That's it. Go cool. All right. Bear with me just a moment. Okay. So, picking up with number 3. All right. That third one down, it says soccer is played with a round ball having a circumference between 27 and 28 inches. And mass between 14 to 16 ounces. What are these specifications in centimeters and grams? Okay, so I want to convert this from inches to centimeters and from ounces to gram. That's what I'm looking to do. So I'm looking over here and I say, okay, I don't see anything. Now I see the 1 inch equals 2.54 centimeters. So 1 inch equals 2.54 centimeters. I need to find a way to get it from ounces to grams. And this is ounce to milliliters, ounce to gallon, grams, I don't know, 1 ounce, pounds, but that's not what I'm looking for. So let's go see if we can find it on our exam handout. So we'll pull these over and see what we can find here. So 1 gram, oh look, it's right there. 1 gram is 0.0353 ounces, or 1 ounce, because I like the whole numbers, equals 28.35 grams. I don't like to work with numbers that are smaller than that. It's just me. So those are the things that I've got. So, okay, I can work with that. So 27 inches. I know that 1 inch is 2.54 centimeters. And this will give me the lower limit in centimeters on this thing. So I can pull my calculator over, not that you really need to watch me do this, but just in case. Sometimes I mess up and things are good. So 27 times 2.54. Again, my inches cancel, and that leaves me with an answer in centimeters. That, of course, is in scientific notation. I don't necessarily want it in scientific notation, so I go second. I didn't want the second. I just wanted the mode. I see that I'm on normal right now, so I hit enter. I change that back to normal mode. Now in a second, quit. And then I multiply by 1 to get that number back in normal. Okay, so that's 68.58 centimeters. That's what it spits out. But this 27 that I have, since it's an estimate, is only 2 sig figs. So I'm going to report this, if I were to report it right now, as 69 centimeters. 5, 8, it would run up to 69. Okay, because it's a non-zero after it, and it's over 5, so 6 rounds up to 69. Okay, so that's one of them. So 69 to something in centimeters. All right, so 28 inches, 2.54 centimeters per 1 inch. Again, inches cancel. I set up the same thing that I did before, so I can say, okay, I want to up to this calculation right here. I want to use that, so I enter it. And rather than using the 27, I want to change that to 28. So I go in, I change that to 28, and I hit enter. And that gives me 71.12 centimeters. Again, 2 sig figs in this 28. So I'm going to report this as 71. So 69 to 71 centimeters. Go awesome. And then we have this 14 to 16 ounces. So 14 ounces and 16 ounces. And what I had written here was that 1 ounce is 28.35 grams. 28.35 grams. So 28.35 grams in 1 ounce. Ounces cancel. 28.35 grams. Ounces cancel. I can set up both of those calculations. 14 times 28.35 is 396.9, and that is grams. Looking at this, I have 2 sig figs in the 14, so I'm going to report this as 2 sig figs. Therefore, this would be 370 grams, or 3.70 times 10 to the second grams. Either one of those is acceptable. Now again, since I want to use that same calculation, but change this number a little bit. Rather than 14 ounces, it's going to be 16 ounces. And we'll calculate that. 453.6 grams. Again, 2 sig figs in this number that I'm starting with here because I'm not counting them. This is a number that was measured somewhere. So that 16 ounces then becomes 454 would be what it would count to if I was doing it that way. But to 2 sig figs, that's 450 grams or 4.50 times 10 to the 2 grams. Okay. Again, that's how we've got it. Excellent. So that's that one. All right. 14. Not 14. 4. That was what I meant, right? How many milliliters are in a 12-ounce soda can? And of course, you can cheat. If you have a soda can available, you can look at that. I, on the other hand, am going to take a look at my exam handouts and see if there's anything on here. And what am I looking for? How many milliliters are in an ounce? Milliliters and ounces. I see mass and weight. I scroll over a little bit to see if I can temperature, volume. 1 milliliter is how many centimeters? And I see milliliters and fluid ounces. And it must be fluid ounces that I'm talking about, right? So if I want to see how many milliliters are in a 12-ounce soda can, I'm starting with that 12 ounces and I want to convert that. And those ounces are fluid ounces. So I can either leave it as an ounce or I can actually label this appropriately as a fluid ounce. All right. And I know that 1 fluid ounce from my exam handouts, it says that's 29.574 milliliters. So I saw that right here. Okay, so that's the figure that I'm looking at right there. Okay, if that's true, then I can take my calculator, move this out of the way. 12 times 29.574. And look at that. Didn't work quite right. But I don't want to have to type the whole thing again. So I'm going to come back and insert and put it at 2. So 12 times 29.754. Enter that. That gives me an answer that spits out 354.888. I've canceled the fluid ounces. And that leaves me with an answer in milliliters. 12 is here, so 2 sig figs is what I want out of my answer. So that's 350 milliliters approximately, or 3.5 times 10 to the second milliliters. Okay, so all of those are acceptable answers for what we're talking about. Okay, awesome. 5. A barrel of oil is exactly 42 gallons. How many liters of oil are in the barrel? And I want to convert to liters. So I need to look for something that's gallons and liters. That's what I'm looking for. I'm going to check my handout here. Gallons. No, that's ounces. It's ounces and milliliters. Don't see it. So now I'm going to try over here. And I'm looking for gallons and liters. Gallons and liters. Oh, I found it. Look, 1 gallon is equal to 3.7854 liters. So 1 gallon, 3.7854 liters. So 42 gallons 1 gallon is 3.7854 liters. So the gallons will cancel, and that calculation should give me what I'm looking for. I don't want that either, sorry. I want this. So 42 times 3.7854. And that spits out 158.9868 liters. Now again, that 42 gallons, I'm assuming is an exact measurement, and it's the best that I know it to. So it's 2 decimal places. So this answer that I've been given needs to be 2 decimal places. So I would report that either as 160 liters or as 1.60 times 10 to the second liters. Notice all of those have units. That's one of my big things. So let's make sure that we've got that. Okay, so that was number 5. Let's talk about number 6. 6 says the diameter of a red blood cell is about 3 times 10 to the minus 4th inches. What is this diameter in centimeters? Well, I know that I had something for this, and I'm actually pretty sure I know what it is, but let's see if I can find it again. So 1 inch is 2.54 centimeters. And 1 inch is 2.54 centimeters. My scratch work can be erasable. All right, cancel the inches. Now, what I'm hoping that you notice is that over and over and over and over and over again, I'm taking the number that they gave me and I'm putting that first. And then I'm multiplying by a conversion factor. And the conversion factor that I have has the unit I want on the top and one I want to get rid of on the bottom, so that I make sure that my answer is on the top. So I want that centimeter on the top, so I get centimeters as my answer. So that's the way I set that up. I wouldn't divide by that, because if I set it up like this, let's just talk about that. 3 times 10 to the minus 4th inches here. And if I did it backwards, I'd have 1 inch here and 2.54 centimeters here. If I were actually to carry this out, whatever this math comes out to be, my answer would be in inches squared per centimeter. And that is not what I want. You'll notice as we continue to go on that I often put it in wrong. I'm like, oh, nope, that's backwards. And that's what I'll say, is because I put the unit in and then I realize that I'm putting it in wrong and the unit's not going to cancel the way I need it to. So I need to go back and set it up again, okay, or take that part out. All right, so that's where that's coming from. And that's always how I'm looking at it, is how do I get rid of the unit I don't want to get the unit that I do. All right, now 3 times 10 minus 4th times 2.54. So 3, oh, not that 3, 3 second EE negative 4 times 2. I enter that, and it gives me 7.62 times 10 minus 4th. And this is the wrong calculation. I got confused because I hadn't crossed it out. So I almost did the wrong math. 7.62 times 10 to the minus 4th centimeters. And I don't need to put that in scientific notation because it's already in scientific notation. If I wanted to take it out, it'd be 0.1237762. Yes, 1, 2, 3, 4, and of course we're moving it that way, so it's -4. Okay, so that's what we're talking about for that. And of course I wouldn't report that without a unit on it. Sometimes I forget it, but that needs to have a unit too. Okay, either of those is fine. I don't care if you choose to report them as normal numbers or scientific notation. It's entirely up to you. Sometimes I do it as scientific notation because it's easier for me, helps with the number of sig figs. And actually, are my sig figs right? That's a darn good question. Are they? Well, it looks like they might be, but that number of sig figs that I've listed there is based on a 2.54, right? 2.54 is exactly known, so we don't use that to determine how many sig figs I have. The only measurement I have is this one, and that is just 3. And that means the answer that I need to report is actually going to be 8 times 10 to the minus 4th centimeters. Okay, we have to round because the only number that I know is that 3 times 10 to the minus 4th, and that's 1 sig fig. Okay, so watch that, because sometimes we get into this assumption that it's whichever one has them, this number or that number or whatever, and it's not always like that. Okay, so we need to make sure that we're using the right ones. Okay, what did I number that? That was 6. 7. Distance between the center of 2 oxygen atoms in an oxygen molecule is 1.21 times 10 to the minus 8 centimeters. What's the distance in inches? Okay, I'm using the same conversion factor that I did before. So remember, we talked about the fact that 1 inch equals 2.54 centimeters. I can cheat, so I'm going to. I'm going to say, okay, I want this, and I'm going to use it again. So I'm going to copy that. And I'm going to move down here. I'm going to paste it down here. And then I can use it. So I put the number they gave me, 1.21 times 10 to the minus 8 centimeters. And then 2.54 centimeters in 1 inch. And do I need to use the abbreviations? Not necessarily. It's entirely up to you. As long as you're consistent, it shouldn't matter. Okay, my centimeters cancel. I'm left with an answer in inches. All right, if I come over here, 1.21 second EE negative 8 times 1, because I forgot that I was dividing by it. So I multiply by 1 and then I divide by the 2.54. Sometimes I do that and I don't bother to go back and delete the multiply. I'm just gonna do it with multiplication by 1 and then division by 2.54. Math comes out the same. Oh, wait, I didn't like that. Oh, because I put in that negative. Sorry, it's the wrong negative. I used a minus sign instead of a negative sign. It does have that problem. So if you do it that way on your keyboard, it doesn't always work. Let's try that again. There, that's a much better number. Now, looking at this answer, I'm just going to write down exactly what it says because that is my habit. 4.763779528 times 10 to the minus 9th, and that's inches. Now I know it doesn't have that kind of accuracy. Now the 2.54 does not determine how many sig figs I should have, but the 1.21 does. They're the same, so I end up with 3 sig figs. 3 sig figs, I end up with 4.76. The 3 is below 5, so I just drop all the rest of this, and that's 4.76 times 10 to the negative 9th inches. Okay, now I'm not going to write all those zeros, but you can if you want to. All right, so that's that one. Cool with that. Okay, let's talk about the next one. Is a 197-pound weightlifter light enough to compete in a class limited to those weighing 90 kilograms or less? So I need to know what that upper weight is, right? To see if he's above or below that. So I'm going to take that 90 kilograms and I'm going to convert that from kilograms to pounds. I need some conversion factor that will do that for me. So what am I talking about when I do that? Well, okay, let's take a look. Do I have anything that looks like it might be kilograms and pounds? I'm looking at mass because that's where my kilograms and pounds are. And look, there it is. So a kilogram, 1 kg equals 2.2046 lb. Okay, so 1 kilogram goes down here. So I cancel those, and that 2.2046 lb goes there. And so I take my happy calculator, 90 times 2.2046, and I enter that. And I get 198.414. 198.414 lb. Now, there are a couple of things I need to consider. So, do I really need to compare the right number of sig figs? No. He's underneath that, so he can compete in this category because he's less than 198. Looking at how many sig figs I should have, reporting it as sig figs, because I have a 9 here and a 0, I could assume that's 2, and that'd give me 200 because it would round to 200, or I can assume it's 1 and it rounds to 200. So, but even if I leave it as this whole big number that it is, the comparison is still, he's smaller than that, so the answer is yes. Okay, now reporting this to the appropriate number of sig figs, I would report this as 2 times 10 to the 2 lb. Okay, and he's still below that, so the answer is yes. Don't forget to actually answer the question. All right. We'll go into number 9, and we're doing some conversions. So 612 grams is how many milligrams? Okay. So we're going from grams to milligrams. At this point, we're not talking about unit conversions. We're talking about some other things. So now we're talking about these metric prefixes. So we're looking at this part of this. So I need to know how many grams are in a milligram or how many milligrams are in a gram. It tells me that 1 gram is 10 to the minus 3. 1 milligram equals 1 times 10 to the minus 3 grams. That's how I interpret what's been written there. Okay. Now the other way that I can interpret this is I'm looking again at the million, it's 0.001, which of course is 10 to the minus 3. Okay, so that's how it works. Now, I can do it that way and use that 10 to the minus 3, or I can say that there are 1,000 milligrams in 1 gram. They are the same. So what I've done is I've actually taken the inverse of the 10 to the minus 3 to see what that number is, and that's how I work with that. For me, that's a lot easier. So if I want to convert it to milligrams, I want that 1,000 milligrams on the top and the 1 gram on the bottom. I'm going to set this up this way and do this calculation. Okay. We're going 612, and then we're multiplying, by 1,000. So 612 times 1,000. 6, 1, 2, 1, 2, 3. That's the way that works. And that's milligrams. And if you want to put the comma in there, you can. Now, what I want to show you, because I have people that argue with me about this, 612 grams. And then they say 1 milligram is 1 times 10 to the minus 3 grams. Okay? Now, like, the math can't be the same. Well, 612 divided by 1 second EE negative 3. Enter. It comes out exactly the same. Now, why am I showing you this? Because I don't want you to be me. And what I mean by that is I refused to believe they were the same until I did this 8 million times. And I can verify to you that if you take the inverse of the number that you've been given, it's the same as multiplying by the, so instead of dividing by the little tiny number, you multiply by by the bigger number, it works exactly the same way. Okay, mathematically, that is no different. So if you want to prove this to yourself, you can do this every time. You can set it up the way that they've set it up. You can set it up the way that I've set it up. It's entirely up to you how you do it. Okay, I can flow with either because I can do the math either way. So I don't mind whichever way you decide to do it. All right, so that's the first one. That was 9. This is A. With B, we've got 8.160 meters, and I want to go to centimeters. So if I look at my handout again, I want to know how many centimeters are in a meter. And it says 10 to the minus 2 or 0.01. So I have 8.160 meters. 1 times 10 to the minus 2 meters in 1 centimeter. So that's exactly as it's written on the thing. I'm not going to do it twice because we just talked about that. And I can do that on my calculator. I'm going to stop showing you the calculator just because I don't want to have to flip back and forth the whole time. 8.160 divided by 1 second AE negative 2. I'll talk you through what I'm doing on my calculator. And that gives me 8.16. Now here's the thing. There are 4 sig figs here, right? 8.160. So I can't just report this as 8.816. I would have to report this as 8.160 centimeters. So don't lose that last sig fig because that would be wrong. Okay? Just a moment. Okay. Oh, you don't need to see that. I need to minimize that. Apologize. It's only a list I'm putting together of the work that I'm doing so that you guys can have that when I'm done with it. Okay, so now we're going to look at number C, and that says 3779, and that's a UG. That's what that looks like. It's actually a micro. That's what that means, and I think that's actually the Greek letter mu. I think that's what that is, but that's what I'm calling it. It's the micrograms, and that is actually micrograms, and you can see that right here, micro. And it says that that is 10 to the minus 6th, okay? 0.05 zeros and a 1, okay? So 3779 micrograms. 1 microgram, sorry, 1 gram is 0.12345 micrograms. Because again, if I do the count on this, the micro, 1, 2, 3, 4, 5, 5 zeros, and then the 1. So again, I can work with that too. 3779 divided by 0.123451. 3779 1, 2, 3, 4, 5, 6. If I do it in scientific notation, 3779 divided by 1 second EE negative 6. Oh, and that gets me the same answer. If I then second mode that, or if I mode that to put that into scientific notation, that gives me 3.779 times 10 to the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, micrograms have canceled, so I'll answer the answer in grams. Looking at how many sig figs I have, 1, 2, 3, 4. So I'm good. 3.779 times 10 to the 9th. Okay, so that is the answer that I would report. So that's C. I'm assuming there's a D, and if there's not, then I'll erase it. D says 781 milliliters to liters. 781 milliliters. I want to convert that to liters. If I look at my milli, all right, it says milli is 10 to the minus 3. That means that 1 times 10 to the minus 3 liters equals 1 milliliter. So 781 milliliters is 1 times 10 to the minus 3 liters, or milliliter. Milliliters cancel. And that then gives me 781 divided by times 1 second EE negative 3. And that leaves me with 7.81 times 10 to the minus 1 liters. And that makes sense to me because I have a bunch of milliliters, but that's actually a really small, it's liters are bigger, so I would expect that to be a smaller number than what I start with. Okay, so that makes sense to me. It has to my smell test. Okay. E. 4.18 kilograms, and I want to get that to grams. Well, I start with what I was given, 4.18 grams. I happen to know that kilo to gram, there are 1,000 grams in 1 kilogram. And you can see that by looking at this table over here, because it says that the exponent is 10 to the negative 3, and not mega, I'm looking at gram to kilogram. Yes, kilo, 10 to 3 right there. So there's 1,000 grams in 1 kilogram. Right? So that's what I set up right there. And so I take my 4.18, I divide that by 1,000, and that gives me 4.18 times 10 to the minus 3. That's in kilograms. Okay. So however you get comfortable working with these sums, I don't care how you do it, as long as you can show me what you did to do it. All right. But again, I need to see your setup just in case something goes wrong. So that is number E. Let's talk about number F. 27.8 meters. It's kilometers. 27.8 meters. There are 1,000 meters in a kilometer. So it's the same kind of setup as what we had before, but instead of doing grams per mile, we're doing meters. Okay, but it's the same conversion. So 2.78 times 10 to the minus 3 kilometers. That's F. Now we can come to G. 0.13 milliliters. And I want to convert that to liters. So 0.13 milliliters. I know that there are 1,000 milliliters in 1 liter. So I've taken the inverse of the number that was provided to me on this table. 0.13, I divide that by 1,000, and that gives me 1.3 times 10 to the minus 4th liters. And again, that makes sense to me. So I have slightly less than 1 milliliter, so it should be way less than 1 liter, okay, because liter is a bigger unit. All right, that was G. That brings us to H. 1738 kilometers to meters. So 1738 kilometers. 1 km is 1,000 meters. 1738 times 1,000 should be 1738. And I'm going to do it 1.738 times 10 to the 6. I could add all the zeros out there if I wanted to. This is meters because my kilometers are canceled. Milliliters canceled. Sorry, dealing with my units before drives me insane. I hadn't canceled any of them. Okay, so there we go. Awesome. Now, this last one, not as comfortable for me. 1.9, and it says G. And what that actually means is gigagrams. Is how many grams? Well, that's an interesting question. I don't know. So I need to see what the relationship between giga and gram is. So giga is that big G, and there are 1 billion grams in a gigagram. So 1.9 gigagrams. 1 gigagram is 1 billion. And of course, that's 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, grams. And so we can do that happy math. And if I'm not mistaken, that gives me 1.9 times 10 to the 9th. Okay. Cool. All right. Questions about that? Okay. Next one we're going to talk about, we've got the make the conversions indicated in each of the following. The men's world record long jump, 29 feet, 4.5 inches to meters. And this is my new A. Well, I have a sort of an interesting situation here. So I can do the conversion from feet to meters and do the conversion from inch to meters, or I can do the conversion from feet to inches and then add all the inches together. And that's typically the way that handles. So 29 feet. I know that there are a number of feet in an inch, or a number of inches in the feet. And I don't remember what they are. So I need to scroll over a little bit. And I see 1 inch is that number of centimeters. I know that 1 inch equals, there we go. At the 39.37 inches is equal to 3.28 feet. It's a weird conversion factor, and I could find another one that isn't the same, but I'm just going to work with that because it's from foot to inches, and that's what I care about. So 3.29 feet is 39.37 inches. And I know I used to sew, so I should remember this, but I can't. So, all right, we can get rid of the feet, and we'll then be in inches. So 29 times 39.27, and then divide that by 3.29. And I end up with 3.461489,362 times 10 to the 2 inches. And then I need to add plus 4.5. inches. So that then gives me 3.506 times 10 to the 2 inches, and I just didn't write the rest. If I were going to round this at this point, I've rounded to 2 decimal places, which would be 3.5 times 10 to the 2. Now, I'm not going to do that because I need to do additional conversions, but that's what we're looking at this point. Now, I still have all those numbers in my calculator. So now that I'm in inches, all right, I need to find some way to get from the inches that I'm in to the meters. And strangely enough, that thing that I was just looking at, 1 meter equals 39.37 inches. So I'm actually using that number a couple of times. 1 meter is 3.28 feet. So if I hadn't done the inch part, I could have done it directly from feet, but then I would have had to convert the 4.5 inches into feet to get that added. All right. That's how I have to do things. So now that I have this lovely number, 3.46, I'm just going to point back to that. And that is okay. And that's inches. And then 39.37 inches in 1 meter. And that lovely thing, I'm going to take that answer that I got times 1 divided by 39.37. And that gives me 8.906 meters. Looking at my numbers, I should have 2 sig figs, so that's 8.9 meters. And that is what I would report. Cool. B. The greatest depth of the ocean at 6.5 miles to km. Starting to set it up already, 6.5 miles. I know that I'm going to need to get rid of the miles. And I see down here at the bottom in the length, 1 mile equals 1.61 km. So 1 mile goes down here, 1.61 km goes here, miles cancel. And so 6.5 times 1.61, that kicks out 1.0465 times 10 to the first. I have 2 sig figs in the 6.5, so 1.0 times 10 to the first, and that was actually kilometers, and so is this, or 10, approximately. Okay, that's how we would report that. So that's my B. Now, let's talk about C. The area of a 8.5 inch by 11 inch sheet of paper in centimeters cubed, or centimeters squared, sorry. Well, this is an interesting one. So I have a couple of options. I can convert the 8.5 inches to centimeters, the 11 inches to centimeters, and then do it from there. Or I can take 8.5 inches times 11 inches, because I know that'll give me inches squared, which is the area. And then I have to get my conversion factor from inches to centimeters. So I know that 1 inch equals 2.54 centimeters, right? We talked about that. So I have no, I want the centimeters on the top. So 2.54 centimeters here and 1 inch here. But I don't want just 1 inch. I need to have inch squared. So that means I need to square both the inch on the bottom and the thing on the top. So I need to square that whole unit to do that. So I need to make sure that I'm multiplying 8.5 times 11 times 2.54 squared. Okay, so I'm going to show you how I enter that on my calculator, just so we're making sure we're talking about the same thing. So 8.5 times 11 plus times 11, and then times 2.54, which has been squared. Now I can do this with PEMDAS. I can put in parentheses. I can, all of that stuff. It's not really necessary. Okay, the squaring gets done first, but it's all multiplication. So if I multiply it all together, it works just fine. I enter that and I get 603.2248. Now I have an inch there, I have an inch there, I have an inch there, cancels with the square there. So that has canceled appropriately. At least we have 603.2246, and that's a 6. I started to write cm with the same thing, and that's centimeters squared. 2 sig figs here, 2 sig figs here, so that means my answer should be 600 centimeters squared, or 6.0 times 10 to the 2. Cool, awesome. The displacement volume of an automobile engine 161 inches cubed 2 liters. Okay, inches and liters, inches and liters. Inches and liters, inches and liters. Well, that's an interesting one. Because I don't remember an inch, which is a length, being related to a volume. But it is. And what I'm going to show you is that we want to get to liters. That means we could go through milliliters, right? And 1 milliliter is equal to 1 cubic centimeter, 1 cc. So 1 ml is equal to 1 centimeter cubed. There are 1,000 milliliters in 1 liter. So I can get from milliliters to liters. I can get from centimeters cubed to milliliters. Okay. But I got to get from inches to centimeters cubed. So 1 inch equals 2.54 centimeters. And if I cube both sides, then that works. Now, how do I put all of that information together to make sure that I get something that actually makes sense? Well, that's an interesting thing. So I know I have 161 inches cubed. That's where I started. So I know I've got that. I know that 1 inch cubed, which is what I have right here, goes on the bottom. If that goes on the bottom, then I have 2.54 centimeters. That is cubed on the top. I don't have to do it first. I can do it here like this. That's fine. So now I'm taking care of this unit. And that got me to centimeters cubed. I know that 1 centimeter cubed from this is 1 milliliter. So now I'm converted from centimeters to milliliters. I know that there are 1,000 milliliters in a liter. And so now I've used that. And so if I look at that, my centimeters cubed cancel with my centimeters cubed, and my milliliters cancel with my milliliters. And so that should leave with an answer in liters if I do all of this happy math exactly the way I'm supposed to. And again, I'm only going to show you this to make sure that you're, thinking about how you enter this on your calculator. 161 times 2.54, which has to be cubed, divided by 1,000. And that leaves you with this number 2 point, and I have 1, 2, 3 sig figs in the 161. So 2.564 liters. Because I knew it was 3 sig figs, so I can round before I do that, and I don't have to report the whole thing. I don't have to write the whole thing down. Now, can you do this as 161 times 2.54 times 2.54 times 2.54? Yes, it's exactly the same. Okay, really doesn't matter. As long as you've taken care of the units the way that you need to take care of them, doesn't matter how you enter this on your calculator, as long as what you did on your calculator is actually the same as what you needed to do. Okay? So remember, when we're dealing with squared units and cubed units, we have to cube the whole thing. And we can't just cube the one and not cube the other part of it. Right? Okay. The estimated mass of the atmosphere. .6 times 10 to the 15th tons to kilograms. And it says that 1 ton equals 2,000 pounds. It doesn't seem overly helpful, does it? Because it doesn't get me anywhere. Well, it gets me out of tons. So I'm going to take it and see what I can do with it. 5.6 times 10 to the 15th ton. I know that 1 ton, 2,000 pounds. Okay, so now I'm out of tons and now I'm in pounds. I'm in pounds, I'm not in grams or kilograms or any of the things that I'm hoping to be in. So let's take a look over here, see what we got with this. We want to be looking at our masses. So 1 pound equals 0.54 kilograms, or 1 kilogram is 2.046 pounds. So either way, I can do that either way. I want the 1 kilogram on the top, and I want the pounds on the bottom. So I'm going to go 2.2046 pounds. Because again, I like to work with the bigger than 1 numbers. So that's the way I would set this up. My pounds will then cancel, and I'll be left with an answer in kilograms. So I'm going to take my 5.6 second EE15 and multiply that by 2,000. And then I divide that by 2.2046. And that gives me 5.08. And I need 2 sig figs, so this would actually be 5. I wrote it like this, times 10 to the 18th, and that would be kilograms, but I should have reported this instead as 5.1 times 10 to the 18th kilograms. Okay, so cool with that. And of course, now that I've crossed this out, I need to initial and date. Okay, so that's E. Let's talk about F. The mass of a bushel of rye, 32.0 pounds to kilograms. Didn't we just talk about this conversion factor? We did. Awesome. So 32.0 pounds. And again, using the conversion factor that I just used, I know that 1 kilogram is 2.2046 pounds. All right. Now, if you use the other conversion factors, you should come up with the same number. Shouldn't matter which one you use. You should come up with the same number, provided that the numbers are actually correct, which occasionally they're not. So let's just go with that. All right. Whatever you use, what you're given. There are mistakes there. That's my fault, and I will take the brunt for that. So this leaves you with 1.451, so 5, rounding to 3 sig figs, times 10 to the first kilograms, or 14.5. G, the mass of 5.00 grain aspirin tablet to milligrams. And I know that 1 grain equals 0.00229 ounces. Again, I don't know where to start. So if I don't know where to start, I just go with what I do absolutely know. I know that I start with 5.000 grain. And they gave me a conversion factor that says that 1 grain is 0.00229 ounces. Didn't really do anything for me yet, but I'm out of grains and into ounces. I used all the information that they gave me, so I'll at least get some partial credit. Now, I can look and see if I can get from ounces to milligrams, grams, kilograms, whatever. And what I see here is that 1 ounce is 28.35 grams. So 1 ounce is 28.35 grams. I'm closer. I wanted to do milligrams. So 1,000 milligrams, because the milligrams go on the top, is 1 gram. And KH 18th August 2024. And that's wrong. So NKH 18th August 2024. Because yes, I actually do that. And this is what my checks look like too. So there you go. Now, that means my grams have canceled. That would leave me with milligrams. So if I do all of this heavy math, that should be set up right. All right. Now you're going to notice that I'm going to start doing this. I get very uncomfortable actually erasing things. It's not my nature. It shouldn't be happening. We tend to work in pen. You are perfectly fine to work in pencil on exams and scratch work, whatever. If you're working in a lab, you should not be doing it. So 5.000. Do I need to put them on? No, but it freaks me out if I don't. 0.00229 multiplied by that, and then multiply by 28.35, and then I multiply by 1,000. And that gives me either 3.24 times 10 to the 2, and actually 3.246. 4 sig figs here. My answer should be 4 sig figs, so 3.246 times 10 to the 2 milligrams, or 324.6. Okay? Oh, that was fun. Take a break for just a moment. I'll be right back with you. All right. We've got a couple more, 3 more that we want to talk about. Many chemistry conferences have held a 50 trillion angstrom run. Okay. I don't know what that means. 50 trillion angstrom, which they say is this A with a thing over it, run. How long is this in kilometers and in miles? Well, I know it's a distance, right? Because it's, how long this particular marathon is. So I look at my thing here and I say, well, is it in here? Nope, actually it's not. So, okay, what else do I have to look at? Well, the other thing we had to look at was that thing from class, remember? Look, there it is. 1 angstrom, which is this thing, is equal to 1 times 10 to the minus 10th meters. And actually, if you look in your exam handouts, this information is there. It's just not where you think it might be. And actually, no, it's not, because they didn't put the angstrom in here. That's so weird. Oh, that's right. Okay, so we found it on there. We can use it from there. Now, if you don't have it on a test, like if I forgot to give you this on a test, you would tell me, okay, I don't know how to do this conversion because I don't know how many angstroms are in a meter, how many angstroms are in a kilometer, but, so what do I do? And that's okay, because occasionally I forget to give you something that you need to know. I do know that I have 50 trillion, and so I'm not sure how many zeros that is, but I know that this says trillion right here, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 50 times 10 to the 12th angstrom. And I know that 1 angstrom is 1 times 10 to the minus 10th meters. That gets me in meters. Now, I want to get to kilometers, so I put 1 km here, and I know there's 1,000 meters in a kilometer. So I can set that up. 50 second EE times EE 12 times 1 second EE negative 10 divided by 1, 2, 3, 1,000. And that gives me, shockingly enough, 5 km, which I would have expected because 5 km sounds like a really normal length of something to run. Okay. Now, if you're good with these things, or if you happen to run things, then you might know what the answer is. Given that it's a common thing, I might let you get away with it if you just said what this was, but I really want you to set this up. So you can either set up this exact same calculation, this one right here again, or you can say I took my 5 km, it should be 5.0, because there should be 2 sig figs because there were 2 sig figs here. At least you think there are. Okay. I think there are. I'm interpreting it that way. So 5 km, and I see that from over here, 1 km, 0.6214 mi. Now, do I have to use that one? No, of course not. I could have used one of the other ones, and that's perfectly fine. It doesn't matter which way you decide to do it. It should work. So I take my 5, I multiply that by 0.624, 0.6214, and I end up with 3.107 miles. Okay, I would report this to 2 sig figs, or 3.1 miles. Okay, cool with that. Again, if I divide my 5 kilometers by 1.61, I should end up with the same number. Yep, I do. And that's good, because I should. That's awesome. So that's one of them. Next one says, as an instructor in preparing for an experiment, he requires 225 grams phosphoric acid. The only container readily available is a 150 milliliter Erlenmeyer flask. Is it large enough to contain the acid, the density of which is 1.83 grams per milliliter? And I look at this and I go, I don't really know what it's asking. I know that I want to contain 225 grams, so I'm going to start with that. Again, I start with what I have been told. And it's grams. I know that this thing is 1.83 grams per milliliter. That's the density of that material. So that gets me out of grams and into milliliters. I'm now in milliliters. I want to know how many milliliters that is to compare it to the 150 milliliter Erlenmeyer flask. So I do this math. 225 divided by 1.83, and that gives me 123, rounding to 3 sig figs, milliliters, or 1.23 times 10 to the 2 milliliters. And so since this is smaller than 150 milliliters, yes, that will work. That container will be sufficient to hold the amount of phosphoric acid that you need. Oh, awesome. See, look at that. I didn't even know what the heck I was supposed to do, but I could take the numbers that they gave me and do something with it. Okay. Now understand that I didn't have to use all 3 of those numbers to do this calculation. One was a comparison number. So do I need them all? Yeah, maybe. I mean, it depends. I write them all down just in case I need them. I want to read that once and then work with the numbers that I have without looking at all the English. In a recent Grand Prix, the winner completed the race with an average speed of 229.8 km per hour, kilometers per hour. What was the speed in miles per hour, meters per second, and feet per second? So I'm going to do 3 conversions here. And I'm starting with kilometers per hour. So 229.8 km per hour. And I'm looking at this going, well, okay, let's get to the miles first because we're already in hours. So let's get to the miles first. And they asked about that first. So how do I get from kilometers to miles? I know that 1 kilometer, based on my handout that I'm looking at right there, is 0.6214 miles. Kilometers cancel, and that leaves you with miles per hour, which is what I'm looking for. So 229.8 times 0.6214, and that leaves me with 142.8 miles per hour. Okay, that's my miles per hour. I got that one, that's there. I now need to go from miles per hour to meters per second. All right. Well, since I don't happen to offhand know how many miles are in a meter, I'm going to start with the time function of this. So I can either set this up and leave this here, or I can say, I'm going to take the number that I just calculated and not use the rounded one, but I'm going to write it down, knowing that I need to use everything that's on my calculator. So miles per hour, I know that 1 hour is 60 minutes, and 1 minute is 60 seconds. Because I can't keep track of how many seconds are in an hour, so there you go, 140. Again, I take the answer that I had. I divide that by 60, divide by 60 again, or divide by 3,600. And that gives me 3.96, and it needs to be 1, 2, 3, 4, 6 figs, so 3.967 times 10 to the minus 2. I canceled my minutes, I canceled my hours, and that leaves me with miles per second. Did I want miles per second? No, so I'm not done yet. So I'm going to take and erase this part because I actually shouldn't have finished this calculation yet. But I can leave it set up the way that it is and then put in the next factor that I need, which is how many kilometers or how many miles are in a meter. Okay? So I know that 1 mile is 1.61 km. And I know that 1 km is 1,000 meters. Now you may see a more efficient way to do this calculation. I understand that, and if you do, that's fine. I don't care how you get between here and there, but if they want meters per second, this will get me to meters per second. So I can take the number that I previously calculated and multiply that by 1.61 and then multiply by 1,000. And that then gives me 63 point, and I need 4 sig figs, 63.86. And that's meters per second. All right. Now I'm in meters. I need to be in feet. So I'm going to take that number 63.86 meters per second. And even though I'm writing that down, I know I'm going to use what's in my calculator to do the rest of the conversions. Okay. I need to get to feet per second. So my time is fine. I need to know how many meters and feet. Meters and feet. I want to get rid of the meters. I see 1 foot equals 0.305 meters. That's in the length section. So 0.305 meters is 1 foot. So I'll divide this lovely number by 0.305. And that leaves me 209.4 feet per second. And technically it's feet per second thing, not just the unit part. Okay. So there's that. Oh my God, that's it. We're done with that one. Now, I'm going to take a break here. I'm going to post this part of this. Then I'm going to talk about the next one that we were dealing with. So I'm going to pause here, give you guys a break, and we'll pick up here again. Hi guys. Now, the matter and measurement, this is the next in-class practice that we're supposed to be doing. This is many of the same things that we just talked about. So what I'm going to tell you is that I will probably get a chance to record a video for this a little bit later. Okay. I need to move on and do a couple of other things at this point. So what I'm going to tell you right now is if you have specific questions about any of these, ask me and I'll record it for you. Otherwise, I will get this posted to the end of this as soon as I can. All right. So that's what I've got at this point. I will do my best to make sure that this gets some answers for you. But if you have specific questions, please let me know. Again, this is all like math stuff until we get into the physical versus chemical changes, and I will make sure that that gets done as soon as I can. All right. Thank you very much. I appreciate by the latest. It should be done by the first weekend of the class. All right. So I will come back to this soon. I appreciate it. Sorry, guys. Thank you very much.